Yesterday, we did the portion of vegetative propagation. Right. We saw how new plants are produced from the body of their parent plant, from different parts of the body of the parent. That is known as vegetative propagation. Now, today, we will see another method through which asexual reproduction takes place in plants. It is called budding. Now, a lot of plants, okay, a lot of plants, microscopic plants, means very small plants, are unicellular, means they have only one cell, okay, they have only one cell. For example, yeast. These plants reproduce rapidly under favorable conditions. Okay, they can increase by thousands in a short period of time. How does this happen? Now, from the time of its formation, one end of the unicellular plant starts growing in the shape of a bulb. Okay, this is the bulb. It starts growing in the form of a bulb. Okay, one part of the unicellular organism. This developing structure is called a bud. The bud breaks off from the parent cell and forms a new cell. Okay, division also takes place here in the bud. Okay, nucleus is divided, cell is divided. Okay, division is taking place, elongation and division takes place. Okay, so the center, from the center, the cell goes, elongates here. Okay, and then it breaks and separates. And this bud portion, okay, this bud portion also divides and makes a new microscopic organism. Okay, the bud breaks off from the parent cell and forms a new cell. Sometimes the division is so fast that a new bud starts forming even before the first bud separates from its parent cell. Due to this chain of buds is formed. In this manner, many microscopic organisms are formed in a small period of time. Understood how budding takes place? Hello, Abraham. Good morning.
Hello, ma'am. Good morning.
Good morning. Can I have your videos on, please, both of you?
Yes, ma'am.
Yes. Now, there is an activity, okay, where you make curd, okay, with the help of milk. You take some warm milk or you take some normal milk and heat it up a little bit. Then you mix a spoonful of curd in it at the center and cover the lid and put it at a warm place, under the sun or somewhere, okay. You cover the lid and put it for 3 hours, 4 hours, and then it will become curd. The whole thing will turn curd. Why? Because rapid reproduction of microscopic lactobacilli bacteria that is present takes place, okay, in the curd. That turns it into curd. That turns the milk into curd. Okay. Then another method of asexual reproduction is called fragmentation. Okay, fragmentation. Now, we have seen algae, okay, in ponds and pools and water bodies, pools and ditches, right? Clusters of slippery green material. If you observe, that is known as algae. Now, what happens? This algae grows rapidly in the presence of water and light. How do they reproduce or grow? The growth of algae is due to a process called fragmentation. Okay, it fragments into two or more parts. Okay, it keeps on dividing itself and spreading. Okay? It keeps on dividing itself and spreading in the you can say on the surface of the pools or ditches or on its sides and walls. It keeps on dividing and spreading. Okay, so that process is known as fragmentation. Then we have sporogenesis. Sporogenesis. In some plants, for example, fungi, fern, algae, etc., the reproduction takes place by spores. Fungi grow on flat bread if it is kept in a moist place, from where And how does this fungal growth takes place on flatbread? Reproduction in fungi takes place through spores. Okay, the fungi on the flatbread are black colored structures known as sporangium. Okay, known as sporangium. Spores are formed in sporangium. Its outer layer ruptures and the spores are released everywhere. Spores are very light, so the air carries them far off. They are covered with a hard outer layer. This layer protects them from high temperature, low temperature, etc. And the spores germinate in favorable conditions and give rise to new organisms. Okay, so these are structures. Okay, these are structures called sporangium. Then spores are there inside it. Okay, spores are there inside it. These are spores. Okay, that are found inside it. Now, if you have seen like a ball-like thing is there, okay, a ball-like soft material is there. Okay, it's also like it has a slightly hard covering. Okay, inside that spores are there. Sometimes we, as a kid, you must have tried to burst it open. So inside, a lot of small parts are there that just flow with the wind. Okay, so those that are inside it are known as spores, and they're so lightweight that they are flown away by the wind. They are carried away by the wind, and um, when they find favorable conditions, that is, um, you can say a good temperature, a good soil, okay, whatever they need to be germinated, that time they plant themselves, okay, they plant themselves and grow into a new organism, okay, grow into a new plant. Understood how sporogenesis works?
Yes, ma'am.
Okay. Okay. Now, next is exercise 5.4. Let's give this a try. Part of the branch where leaf comes is called as node. Is it true or false? Abraham,
True.
potato does not contain ice. True or false, Emma?
Uh, I think true. No. Yeah.
Hmm.
No, it does. It does. It's false.
False. Yes. In sexual reproduction, new plants are produced by leaves. Abraham,
True.
think again, Abraham.
False.
False. Why? Because they are produced by seeds, not leaves. Okay. Formation of yeast is by budding. True or false, Emma?
True.
Formation of fungus is by spores. True or false?
True.
Okay. Fill in the blanks. Land grows without dash asexual reproduction. I don't know. I think there is a printing mistake or something here. Land grows. I don't know. Second one, when plants are produced using somatic parts, it is called dash propagation. Emma?
I don't remember.
You don't remember? Abraham, you remember? Second one,
No, ma'am.
vegetative propagation. We just did this yesterday. Okay. Next, outer edges of the biofilm leaves contain
Plants.
Yes, we can say new plants, but
Saplings.
saplings, yes. Let's quickly check it out. Buds. Answer is buds, okay? Algae growth is by
Cell division. See, fragmentation.
fragmentation. Right. From which somatic part of the body somatic propagation takes place in the plants? It can be more than one part. Yes, you can. Somatic parts can be the surface of the plant, okay? It can be the leaf, okay? It can be its surface itself, it can be root, okay? Anything from which the somatic propagation takes place, okay? Then, what are the two important characters in somatic propagation? This you have to write down. Now, today let's begin with sexual reproduction in plants. Okay. Now, the flowers play an important role in sexual reproduction because the sexual organs of plants are present in the flowers. Okay. The sexual organs of plants are present in the flowers. They are of two types. In plants, they are of two types: male reproductive organs, which are called androecium, and female reproductive organs called gynecium. Okay. With reference to the reproductive organs, flowers are of two types. Now, according to the what reproductive organs are present in the flowers, they are of two types. One is called unisexual flowers. They possess either only androecium or gynecium. Means they will either have only male reproductive organs or female reproductive organs. These are called unisexual flowers. For example, maize, papaya, cucumber, and gourd, etc. Okay. Then we have bisexual flowers. These flowers have both androecium and gynecium, both male and female reproductive organs in the flower. So they are called bisexual flowers. Flowers of mustard, hibiscus, rose, sunflower, etc. are all bisexual flowers. Now, male and female unisexual flowers may be present on the same plant or different plants. So male and female unisexual flowers, okay, can be there in the same plant. In the same plant, it may be possible that there are some flowers which are male, which have male reproductive parts, and some plants which have the female parts. But it is also possible that in different plants, one plant is only the male, okay, all the flowers have male reproductive parts, and another plant has female reproductive parts. That is also possible. Okay, but in maize, okay, in maize, we have the male and female flowers are present on the same plant. In the same plant itself, they have male and female flowers. Okay, now, what is the structure of androecium and gynoecium. Okay, so androecium is the main part, is the male part of the plant. Okay, it has two parts. Okay, it has two parts. Stamen. It has two parts, anther and filament. Okay, see, in each type of flower, the number of stamens are different. Okay, so these things, if you can see, these things are known as stamen. This whole thing is known as the stamen. Okay, this whole thing is known as a stamen or the male reproductive part. In the stamen, there is two parts. Okay, this top part and this filament-like part. So the top part is known as anther, and this filament-like portion that it has, it's known as filament. Okay, filament. So anther is a small sac-like structure and it contains pollen grains. Okay, it contains pollen grains, and these pollen grains are the male gametes. Okay, male gametes. Then we have this center portion. This center portion that is the female reproductive part. The whole thing, okay, is known as gynoecium. It has an ovary, style, and stigma. Okay, let me show you an English diagram. One minute.
Yes, ma'am.
Now, if you can see in this diagram, you can see in this diagram, this is anther, okay, the male reproductive part, okay, it's known as stamen, okay, stamen or androecium is known as stamen. It has two parts. One is known as anther, another one is filament. Okay, can you see anther present here? This is anther, and the tube-like thing below it, with which it's connected, is known as filament. Okay, then there is the female part, the honor hole, they are known as pistil. Altogether, we call it pistil. This pistil has three parts. Stigma, okay, means it's the opening at the top. Tube, style means neck of the tube, and ovary means this portion. This inside portion is known as ovary. Now this ovary, it has ovules, okay? Small structures known as ovules, okay? Inside the ovary. The outer leaf-like thing that gives protection to the flower are known as sepal, okay? And these colorful parts of the flower are known as petals. Okay? Now, what happens? How does this fertilization takes place in flowers? This anther, okay, this anther, from it, the pollen grains fall into stigma like this. Okay, they fall into stigma. Then through the stigma, going through the style, they come into ovary, and then they fertilize with the ovules present in the ovary. Okay, they get fertilized with the ovules present in the ovary. Okay, that is how the pollen grains and the ovule, they are combined, and then fertilization takes place inside the flower. Okay. Now, once it is done, okay, the flower, okay, it becomes a fruit. The ovary, okay, the ovary. This is the ovary is the portion which becomes a fruit, okay, which becomes a fruit. And in the fruit, we have seeds. Okay, we will have more seeds. So now, when the seeds are planted, they become new plants. Okay, so that is how reproduction in plants takes place. Understood? Firstly, tell me, understood all the parts of the plant? Any doubt in this?
Yes, ma'am. Understood.
Okay. Abraham?
Yes, ma'am. Understood.
Okay. Okay. If you've ever opened up a flower of hibiscus, you will be able to locate all of these parts. Okay. If you look closely at a flower of hibiscus, you will be able to locate all of these parts. Now, now there is a term called pollination. Okay. What is pollination? Pollination is when um, pollination is when this whole process happens of pollen grains reaching the ovule. So pollen grains reach the ovule through the stigma. The transfer of pollen grains from anther to stigma is called pollination. Like I said, pollen grains go from anther, enter the opening of stigma, go to the style, and then reach the ovary. Okay, so this transfer of pollen grains that happens is called the process of pollination. Now, how do they transfer? How do they get transferred? See, they can be transferred by air since pollen grains are very light in weight. They can be carried out by air, carried away by air, or they can be carried by water, or they can be carried by insects, okay, like bees and all. When bees sit on one flower, its pollens stick on their legs and their body. And when they go and sit on another flower, then those pollen grains from the previous flower gets transferred to the another flower, which does what? Which pollinates it. Okay, so that is how pollen grains are transferred. They are covered by Generally they are covered by strong envelope which saves them from dissection. Okay, they have a small covering also which helps them not to desiccate, okay, or dissect. Now, why are flowers so colorful and fragrant? Okay, insects get attracted by the color and scent of flowers and they come visit them. At that time, the pollen grains adhere to the body of the insects, means the pollen grains stick to the body of insects. When the same insect visits another flower, some of these pollen grains fall on its stigma. In this manner, pollination takes place by insects. Okay, now there are two types of pollinations that are there. Okay, two types of pollination that are there. One is called self pollination, another one is called cross pollination. What's the difference? Self pollination is when the pollen grains fall in the stigma of its own flower. Okay, means like in the first seed it's happening from the anther, it is going into its own stigma. This is known as self pollination. Okay, another one is when the pollen grains go from one flower to another. Okay, transfer of pollen grains takes place from the anther of one flower to the to the stigma of another flower. That is known as cross pollination. Okay, understood the difference between self and cross pollination? Any doubt? Okay, so we will stop here for today. Okay, and tomorrow we will talk about fertilization. in plants. Okay. There is a break for you all for 5 minutes and then we'll start. Hello, Nathaniel. Good morning. Okay, so let's begin. Hope you all are there.
Yes, ma'am, I'm there.
Okay. Okay. So yesterday we saw how to find out the square of a number, square root of a number using prime factorization, or you can say factorization method. Today we'll check out how to find the square of a number by using long division method. By using division method. I want you all to pay attention and look very carefully. Okay, look very carefully to what are we going to do. Okay, step by step we will go. For example, let's take any number. Let's take a number which you have to find out the square root of. For example, 1225. Okay, 1225. So the first step is we divide the number into pairs from right to left. Okay, we divide the number into pairs from right to left. So I have four numbers. How many pairs will be there? Two pairs. 1, 2, 2, 5. So 25 will be one pair and 12 will be another pair. Okay, 12 will be another pair. All right. From the right side we divide. Okay, that is from this side. From the right side to the left side we divide. Okay, so now that was the first step. Okay, what is the second step? Take a look at the first pair. Now from the left side we will start doing it. The first pair is 12. So what perfect square should I take that is either 12 or is lesser than 12? It's lesser than 12. So you have to remember these. 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, and so on. So 12. I have to take a number that is only the square number I have to take. Okay. So 3 threes are 9 I can take because 4 fours are 16 will be way bigger. Right, 4 fours are 16 will be bigger. So 3 threes are 9 I can take. So I will take 3 threes are 9. Write 3 here and write 3 on the top. Okay, because we're doing 3 times 3. Okay, how much? 9 minus 3. Okay, now the next step is listen very carefully. The quotient that is there on the top, the quotient or the number that is there on the top, we add it to the side. Okay, 3 is there on the top, so we add 3 here on the side. So it becomes how much? It becomes 6. We add 3, so it becomes 6. After 6, we put a dash here. We put a dash here. Okay, once you add it, we put a dash. Then I will copy the next number, but I will not just copy 2. I will copy the whole pair, 25. Okay, why we made pairs at the start? So that when we bring them down, we can bring down the whole thing. So I will bring down the whole 2 and 5, 25. Okay. Now I have to find a number to place after 6 in this blank. I have to find a number to place after 6 in this blank. that when I place it there and multiply it with itself, it should give me 325. It should give me 325. Okay. So, am I audible?
Yes, ma'am.
Yes, ma'am. And this will only work for 4-digit numbers.
Okay. So, I have to find such a number. Right. Then, suppose I place 4 after 6 in the blank. So, I have to check out with 4 itself, multiply it with 4 itself, and check how much I'll be getting. 4 4s are 16, 6 carry 1, 4 6 are 24, plus 1, 25. 256 is smaller. Then let's try out with 5. 65 into 5. 5 5s are 25, 5 carry 2. 6 5s are 30, plus 2, 32.
65 only.
Yes, 65. So write 5 here, write 5 on the top, and write 325 here. And then we subtract it and then 0. So 65 is there. Okay. 65 is there. And that is how we do it. Okay. That is how we solve it.
The
So
answer is
answer is 35. Okay. The answer is 35. Okay. Understood? One more I'll explain you. One more I will explain it.
Ma'am, but how did you get?
Say one by one. Yes, Emma.
Ma'am, how did you get 35 on the top? I was thinking.
How did I got 35 on the top? See, first I got 3. Okay. I got 3 threes. I can only take the numbers such as 2 into 2, 3 into 3, 4 into 4. Okay. Square numbers. So I took 3 into 3, then I got 9. Then that 3 which is on the top is also added to the side. See, the numbers that we put on the top, the quotient, we keep on adding them on the side also. Like this 5. This 5 also will be
Yeah, I got
added.
it. And then the 5 will also be added to the top.
Yes, so it will become 70. Okay, it will become 70 dash for the next one, but we don't have the next one. Okay, so that is why you don't need to add it. Okay, see, one more I'll show you with an odd number. Okay, this time I'll show you with an odd number. Okay, let's take
the sum is with an odd number.
yes, let's take 529. Root 529. Okay, so this is the format. First, make a big bracket like this. Write 529. First rule, make pairs. So I have only one pair, 29. And 5 is 11. So what to do with this 5? I will take this 5 only. Because 5 was not able to find a pair. There was no pair for 5. So 5 individually I will take. Okay. So 2 twos are 4. And 3 threes are 9. 3 threes are 9 will be bigger. So I will take 2 twos are 4. 2 twos are 4 minus 1. Okay. Now I will add 2 again to the side. I will add 2 to the side. So it becomes 4 and then put a dash. Then bring down the next pair, that is 2 and 9. 2 and 9. Now what number should I sorry. What number should I write in front of 4 that when I multiply it with that number itself, it will give me 129? And I have to find out. Okay, so we can try out with 2. We can try out with 2. 42 into 2. 2 twos are 4, 4 twos are 8. I'm only getting 84. Let's try with 3.
Ma'am, it will only work with odd numbers because the IMU digit is an odd.
Yes, we can try with odd numbers. 3 threes are 9 and 4 threes are 12. There I get, and there I got it.
The
129.
answer is 23.
The answer is 23. Okay, 129 and 0. Hope you all are able to understand long division.
Yes,
Yes,
ma'am.
ma'am.
But this method is longer than the other method, right?
Yes, this method is longer. Okay, but if you do it quickly, then this method can be shorter also.
Yes, ma'am.
Abraham, you are muted. Abraham, you are muted.
Ma'am, I think this method is better.
You think that which is better?
This method.
This method.
Because you're not thinking so much as you think in the right factorization. And
Yeah,
then there's
so
not like the dead ends, like 14 and 12. You just need to know squares 10 or 10. That's all. And that's very easy.
yes, once you get used to this method, it's quite simple. Once you get used to this method, it's quite simple. If you are like easily able to find. Okay. Now, I want you all to try out. Shall I clear the screen if you have written it?
Yes, ma'am. Ma'am, can we do a sum for ourselves?
Yes, I am going to give you all sums to try for yourself. Just 1 second, 1 minute. Please try out finding the root of 5630. Also find
Ma'am, we can't see your screen.
now. Are you able to see my screen?
Yes, ma'am.
Okay.
Ma'am,
Yes, Abraham.
I mean, the first one I'm finding a little bit difficulty. When I'm solving a sum, I'm hitting 730. And then after that, I'm not able to find anything divisible that is able to divide 730. Should I just find something close to 730 or will the number be exact?
Abraham, find something close to 730.
Okay, ma'am.
Ma'am, I'm messing up. You have to take 56 as one number, right?
Yes, Emma, we take 56 as one number and 30 as one number. Make pairs, okay? First step is make pairs.
Ma'am, can you please solve the first one you gave on the screen, ma'am? It is coming to something I'm not able to understand.
Yes, ma'am,
Okay,
it's coming.
okay, sure.
And at the end, it's like ending with a three-digit number. It's ending with a four-digit number, and then we have to divide it by a three-digit number. It's impossible.
And I was getting at the start two numbers because 56
Ma'am,
is like 20.
ma'am, after that step, you can't pull down anything. That's the problem.
Mm-hmm. 5, 6,
Ma'am,
3.
when I was doing the 56 part, I like 44 because that's the closest number I could get. But then 22 was
Ma'am,
like
49. 49.
you got 49.
Yeah, because 7, 7
So
is.
yeah, 7.
Then 3 and 0, bring it down.
See, ma'am, 730. Then you plus 77, which is 14.
Yes, 14. And put a dash.
Then, ma'am, I put 4.
Okay, did you try with 5?
This time I tried with 5. I was getting 7, 5, 5. So it was getting too big.
5 5s are 25, 5 carry 2, 5 4s are 20, plus 2, 22, 2 carry 2. 5 1s are 5, plus 2, 7. So 5 only we will put 5, put 5 up, 725. Subtract it and 5. Okay. So here, actually the exact root will be in decimal. Okay. It is going to be in decimal. So we, if you want, you can put a point here and put a 0. Okay.
Ma'am,
Or
like
yes,
questions won't be asked, right?
such questions won't be. Yes, usually such questions are not there.
And it's
Okay.
because so first we have to check for the square root and then we have to see. So if you check for it, right, ma'am?
Yes, usually such questions are not there. Okay. But if it comes such as this question, then what you can do is, if you're getting a remainder, then you can write that the root of 5630 is 75 approx. Okay. You can write it 75 approx, so that it will be, so that we'll be able to understand that it is close to 75. Like I checked the exact, it's 75.03 in this question. It's 75.03. So even if you write 75 approx, that is also correct. Okay. When such things happen that you are left with a remainder, okay, just write the above quotient and write approx with it. Okay.
Ma'am, for finding the
Yeah.
square, for checking whether it's a square, can we use the
Can we use what?
root?
Calculator?
No, root.
BGU, Byju's.
Ma'am, no, it's root. Digital root.
Acha, DigiRoot, yes. Okay, DigiRoot, yes. Yes, you can try with DigiRoot. Okay, you can try it with
There will be
DigiRoot.
questions using division method also, right?
Yes, Emma, there will be questions using division method. Okay, there is going to be questions, and mostly they will be perfect squares, so you will not be left with a remainder, mostly. But if there is that by chance any question comes in
Then
which,
you just put approx.
then you just put approx. Okay. Okay.
Ma'am, we
Try
can
out.
that question.
Ma'am, should we do the next question on our own?
Yes. Do the next question on your own.
Ma'am, this is not divisible.
2304.
No, ma'am. Root is coming to 8. 2 plus 3 is 4. 4 plus 4 is 8.
5630 is not divisible.
No, 2304.
2304. 2304 Abraham. DG root is coming to 8. Okay. Solve it, Abraham. It is like completely divisible.
Okay, ma'am. Ma'am, the root is for square is 1479. No, ma'am.
You just check it out from the notes that I sent.
No, ma'am, I
Okay.
checked. Ma'am, I've checked it out from my written notes. It's 1479.
1279.
No, 1479.
1479. Okay.
What is the answer? 48.
Yes, Abraham, 48 is
And
correct.
the answer 48.
48 is correct, Emma. Well done, both of you all. Nathaniel, getting?
Yes, ma'am, I also got 48.
You also got 48. Okay. Let me just quickly write it down so that you can cross-check. 2304. We started with 4 4s are 20. 3. Then we brought down 0 and 4. Oh, sorry.
And 4 4s are 16.
Yes, 16. 16, yes. 4 4s are 16. Subtract 7. And then 0 4. Add 4. 8. And a blank. Now, what we will put? We will put 8 here and 8 here. When we do it with 8, 88 into 8, we will get 704. Okay. So 48 is the answer. Now, hope you all understood how we work on this,
Yes, ma'am.
right? Now, for the homework, let me give you some questions. You have to try this out with long division and send me. Four questions are there. Okay, please write this down. Do it for homework today. And then send it to me. Or you can just post on the group. Okay. So tomorrow we will try out with bigger digits. 5 and 6 digits we can try out tomorrow. I'll check in our course if we have 5 to 6 digits. I think we do.
Ma'am,
Yes, Abraham.
no, I found out what went wrong in the digital route. 2 plus 3 is 5, not 4. So the answer is 8, 9, not 8.
Where, Abraham?
Now in the digital route, I made a mistake while calculating it. 2 plus 3 is
In
5.
the digit. Okay. In the digi route, you made a mistake.
That's why I came to 8, not 9.
Okay. Yeah. Okay, Abraham, I understood now. Yeah. So please try out these 4 questions at home today. Okay. And tomorrow we will try out some questions with the bigger digit, and then we will move on to cube and cube roots. Okay. That's all for the class today. I will see you all tomorrow.